All right, we're in our last unit, our last topic in Unit 3A. And our last topic is about calculating rate of change or speed. So on the graph to the right, it describes Emma's walk, and pay close attention to the x and y-axis. The x-axis is time. The y-axis is distance, and each unit of the x-axis is 5, 10, 15, 20. Each unit of the y-axis is 1,000, 1,000, 2,000, 3,000, 4,000. So over here we say in past examples we've focused on writing a story given a graph. We can also use this graph to determine the speed at which Emma is traveling. So to calculate speed, we're going to see how long it takes Emma to travel a certain distance. So I'm going to figure out how fast Emma is traveling on this section of the graph right here. And to do that, I'm going to look at this point. I'm going to pick this point right here. This point is 25, 5,000. So Emma travels 5,000 feet in 25 minutes. And this example is worked out for you, so let's just walk through it. This first part says change in distance over change in time. Change in distance, I'm going to write what that means, the triangle. Change in distance. Remember, we said distance is the y-axis, so that really means change in y. Time is the x-axis, that really means change in x. So this is just the slope. That's what we're finding. What's the slope? Alright, so how much Emma traveled between where she started to where she ended is 5,000 feet. The amount of time it took from where she started to where she ended was 25 minutes. This last step right here, how we went from 5,000 over 25 to 200 over 1, is we reduced this fraction. I know those are big numbers, but 5,000 over 25 is really 200 over 1 as reduced fraction. So Emma's speed is 200 feet every 1 minute, and this is our final answer, 200 feet per minute. She's traveling pretty fast. So this next part says you can also calculate Emma's speed by finding the slope between any 2 points on her path. So again, remember, we're talking about this portion of her graph. If I want to find out how fast she's moving, I can pick any 2 points on this graph. So I'm going to pick a couple random points. I'm going to pick this point right here. That point is 5 and 1,000. And I'll pick the ending point that we already know, which is 25 and 5,000. And I'm going to calculate the slope by stacking these. So 25, 5,000, stacked over 5, 1,000. And if I subtract those, I get 5,000 minus 1,000, which is 4,000. And 25 minus 5, which is 20. Finally, we write our answer as a fraction. So our answer as a fraction is, I'll write change in y over change in x, is 4,000 over 20. To reduce this fraction, I can divide the top and the bottom by 20. And I get as my final answer, 4,000 divided by 20 is 200. 20 divided by 20 is 1. So for the last step, we just have to put units. So I'm going to put 200 over 1 is my final answer. 200 represents distance, so it's 200 feet per every 1 minute. And really that means 200 feet per minute, the same answer as we had above. 50, and dividing by 50 down here. 100 divided by 50 is 2, 50 divided by 50 is 1. So our final answer is 2 over 1, which really is just 2. And our units are, remember, the 2 stood for, what was our units? Meters. And our time was in seconds. So I'm going to write SEC for seconds. So our answer is 2 meters per second. All right, next example, we're going to talk about section B. I'm going to choose a different color for section B. So for section B, we just have to pick any 2 points on section B. So your section B, I'm going to pick any 2 points. I'm going to pick the starting point again, which is 50, 100. I'm going to pick the ending point of B, which is 70, 40. And to calculate the slope, I'm going to stack and subtract. So I'm going to put 50, 100 first, and 70, 40 second. Now, stack and subtract. 100 minus 40 is 60. 50 minus 70 is minus 20. Next, I write my answer as a fraction. So I do change in y over change in x. 60 over negative 20. I'm going to reduce it. 60 I can divide by 20. 20 I can divide by 20. 60 divided by 20 is 3. 20 divided by 20 is negative 20 divided by 20 is negative 1. So my slope is, I'm going to actually put the negative in front. It's negative 3 over 1, which is negative 3. And remember, our units are meters per second. Our slope is negative this time, and the reason is because this person is traveling backwards towards home. Alright, we're moving on to section C. So for section C, I'm going to pick 2 points, starting and ending. You can really pick any points. My starting point is 70, 40. 70, 40. My ending point is, what is that? 100, 160. Okay, well, now we're going to find the slope or the speed between these. So I'm going to actually put this point on the top when I stack and subtract, because my points are bigger. 100 and 160 minus 70, 40. And I'm going to do 160 minus 40, I get 120. And 100 minus 70, that's 30. Now we write our answer as a fraction, 120 over 30, and we reduce. I can divide the top and the bottom by 30. So my reduced answer is 120 divided by 30 is 4. 30 divided by 30 is 1. So my answer is 4 over 1, which is just 4. And my units are meters is the change in y. Seconds is the change in x. Now if you compare this to section A, remember section A was 2 meters per second. And so we have 2 different speeds, 2 meters per second and 4 meters per second. 4 meters per second is faster. What we talked about in previous units, if I look at this graph, you can tell that something's faster if it is steeper. And section C is steeper than section A. So it should make sense that it's faster at 4 meters per second. Okay, so our last example is section D. Section D, you might notice right away, section D is flat, which means that the person walking is actually not moving at all. They have stopped. But we're going to still just evaluate that, find our slope. So the starting point of section D is 100, 160. Oops. 100, 160. And another point on that graph would be 120, 160. Here and here. Alright, so we'll stack and subtract. 120 over 160 minus 100 over 160. When I subtract, 160 minus 160 is 0. 120 minus 100 is 20. Our fraction is 0 over 20, which is really just 0. So the speed is 0 meters per second, which means the person is stopped. They are not moving. And that makes sense in the previous stories that we've talked about in other units. All right, next you should move on to your homework, 3A packet, and do the homework associated with this unit. Good luck.